Okay, welcome back. I hope you did well on that second question. Just taking a look at it here with the x plus 2. I guess the tricky part is that the a value would be minus 2. So you're going to be substituting a negative 2 into that polynomial, and the remainder was 45. So hopefully you got that okay. Question on the bottom says, does a polynomial have to be written in descending order to use the remainder theorem? Looking at this question that we just did, it is written in descending order, isn't it? This is x to the fourth, x to the third, to the second, to the first, and then to x to the 0. So this is written in descending order. What if it was written in a different order? If we started with the minus 5x cubed, for example, and we plugged in the negative 2. Well, as long as you're following the rules of, like, if we wrote this term first before this other term, you're still going to get the same answer, aren't you? So does a polynomial have to be written in descending order to use the remainder theorem? No. When is it really important to write it, the polynomial in descending order? It's important for synthetic division, because that's when we are not writing our x's each time, so the order is actually telling us which order of x you have, if that made sense for you. This gray box here tells us this factor theorem, and we've kind of deduced it already. For a is a member of any integer, if a is an integer, then x minus a is a factor of a polynomial p of x if p of a is equal to 0. So if this remainder, in this case if it was 45, if that remainder is 0, when the remainder is equal to 0, or another way to say it, if p of a, right, is equal to 0, then x minus a is a factor. So we could rewrite that. It's another way of writing this. Okay, moving on to the next page. I'll hide these solutions. There we go. Example number 2. Which binomials are factors of x cubed plus 2x squared minus 13x plus 10? Which of these 4? Now they give you 4 already, so you don't have to come up with them yourself, and they're saying, is this a factor? Is this a factor? Is x minus 2 a factor? Is x plus 2 a factor? Is x plus 5 a factor? So the way you do this, using our remainder theorem, is you say, okay, in this one, a is equal to 1. And then, so really the test is p of 1 equal to 0? Right, so we're going to say in this case, first question, I'll go down to our solution over here. P of 1 is equal to, so they've just rewritten this polynomial down here. Instead of x cubed, now they're at 1 cubed, just like we were doing before, and they found it was 0. So the first one is yes. So I'll just put a little check mark. Yay! X minus 1 is a factor. B, the second one, is 0. Yes, it's a factor. C is 36. So x plus 2, no, is not a factor. And the last one, D, is a factor. So you'll notice x minus 1, x minus 2, and x plus 5 is all a factor. It's kind of cool if you think of this. This is completely factored. I'll just take a moment here. The questions won't always work quite so neatly, but check it out. If I say this, in fact, the 3 solutions that we just found are that polynomial completely factored, and I'll give you some hints of why I know this. X plus 5. So those were the 3 factors. So if I multiplied x minus 1 times x minus 2 times x plus 5, which is a little bit of work, I would probably do x minus 2 times x minus 1 and using FOIL, and I would get some trinomial, and then I'd multiply that, each of those 3 terms that I got, by x, and then I would have to multiply each of the terms by 5 and then combine like terms, but I would get this. And how do I know that this is equal to that? Well, my first term, x cubed, is just going to be a product of x times x times x. Since these are all 1x, and it's not 2x or 3x, it's just x by itself, then I know that this also is going to have a coefficient of 1. So since these coefficients are all 1, the product of 1 times 1 times 1 is 1. So that works. And check this out. The minus 1 and the minus 2 and the plus 5. If I multiply those out, that gives me this plus 10, because negative 1 times negative 2 times plus 5 is plus 10. So since those both work out, I know that this polynomial completely factored is x minus 1 times x minus 2 times x plus 5. Alright, so for the check your understanding, it looks like they only have one question here for the check your understanding, so I'm going to get you to work on this without me doing the example. Which binomials are factors of x cubed? Well, I'll tell you what, I'll give you a break. I'll do part A here. Which binomials are factors of that? So I'm going to plug in p of 1, which is equal to x cubed, that's 1 cubed, minus 6 times 1 squared, so I'll just say minus 6, plus 5, plus 12. So 1 plus 5 plus 12 is 17. 17 minus 6. You know what? All I got to do is figure out whether or not it's equal to 0. I don't actually have to figure out the remainder, because I'm not interested in the remainder. I'm just in per se. All I need to know is the remainder 0? And if the remainder is 0, it is a factor. Since this remainder is not equal to 0, this is not a factor. So far that one's not a factor. Oh heck, I'll do B for you as well, and then you can do C and D. So oh, I made a mistake from the first question, didn't I? Oh, my A should be equal to negative 1. Looking back at this, so I'm just going to say I'm not quite sure it's not a factor. I'll put a negative 1 here. So this is negative 1 cubed minus, oh, you know what? Let me just write this all better. I'll do some erasing here. Okay, so I'm going to get negative 1 cubed minus 6 times negative 1 squared plus 5 times negative 1 plus 12. So negative 1 multiplied by itself an odd number of times is going to stay negative. Negative 1 multiplied by itself an even number of times, this becomes positive 1, and then it gets multiplied by negative 6, so it's negative 6. 5 times negative 1 is minus 5 plus 12. Negative 1 and negative 6 and negative 5 is negative 12. Negative 12 plus 12 is equal to 0. Oh, it's so good I caught that one. So the remainder is 0, so this is a factor. Cha-ching. Okay, I'll still do B. The thing to watch out for, you just saw me make that mistake, is I don't plug in a negative 3, I plug in a 3. So I'm going to say P of 3 is equal to 3 cubed minus 6 times 3 squared plus 5 times 3 plus 12. So 3 cubed is 27 minus 6 times 9, which is 54, plus 15 plus 12. 27 plus 15 plus 12, 20, 30, 40, 54. Yeah, I think it works out to 0, doesn't it? So that's also equal to 0. So this is also a factor. Okay, I'm going to get you guys to finish C and D, and I'm just going to stop the recording now.